Today we're going to continue the notes for 1-3, which is graphs of functions. Yesterday we talked about how to, what did we talk about? We talked about how to graph a function and find the domain and range from the graph, which is left to right is the domain, bottom to top is your range. We talked about that it was going to be an interval notation. Okay, a lot of the stuff that we're doing today will continue to be in that interval notation. So we left. Okay, so yesterday we talked about how to find the zeros or setting our equation equal to 0. We talked about our increasing and decreasing behavior being from left to right. The other thing, I don't know if we added it on there, but to give increasing and decreasing behavior, it will be an interval notation, but we use the x values, not the y values. So as we go from left to right, we would say it goes maybe from negative infinity up to the first x, God bless you. And again, we'll always use those x values to show increasing, decreasing. So if you had something like this, let's say, okay, then if I was to identify our increasing, decreasing behavior, we go from left to right. So the first movement is upward, which means that would be increasing from negative infinity to negative 2 with a parentheses on the negative 2 because, again, a point cannot be increasing, so we use parentheses. Then it's kind of not horizontal, but my intent was to make that horizontal. Then it would be constant from negative 2 with a parentheses on the negative 2 to positive 2 with a parentheses on the positive 2. And then it comes back down again, so it'd be decreasing from 2 to positive infinity. We talked about the fact that they are mostly parentheses, almost always. The only time they would not be parentheses is if the end of this graph ended in a horizontal line with a solid dot. Then it would end constant, and that value and only that value would get your bracket. Good morning. Questions on that? Okay, then we went through max and min. Remember, this is in coordinate point form, and this is relative, so there can be more than one max and more than one min. We did this one on the graphing utility, and we left off with graphing piecewise functions. So we evaluated piecewise functions. Like if I said find f of -1, I wouldn't know to go to the top one. I would plug it in there, and I'd get my value. But now you're going to graph these, okay? There are two methods to graphing piecewise functions. I'm going to teach you both. You get to choose. And I go back and forth between the two methods, and I'll tell you why, okay, after I explain them both. The first is graph the entire thing. So I'm going to first graph this one, which would be y equals 2x plus 3. What kind of graph is that? Line, good. I would start at positive 3, and then I would go up 2 into the right one or down 2 into the left one, and I would draw my line. That would be if it was by itself. Then I look at the range I actually want to keep the graph of, which is less than 0. X is less than 0. So I want to go on that graph I just drew where x is equal to 0, which is that y-intercept, and I want to go left of it. Less than points this direction. And then I would erase everything else, including the inside of that dot, because this is not or equal to, it is less than. So keep in mind, obviously, you're going to eventually do this on a piece of paper. You would literally just erase that with your pencil, okay? And then you would make sure that dot right now is open, right?
Wait, isn't x equal to 0 too?
No, that's the bottom one. So the top one, you mean what did we just graph would be equal to 0, or you mean the equation is equal to 0?
Like the thing, like.
So because it says not equal to 0, it says less than 0, we give it the open dot. Does that?
Because it was like equal, you have to have like the hard circle.
But it's not equal. That one says less than, not less than or equal to. If it said less than or equal to, now it would be a solid dot.
Oh, we're only doing the first.
We just did the first. Then we're going to do the second. So this is the first method. Graph them, erase what you don't need. Okay, so now I'm going to go to the second one. And the second one would be y equals, I'm going to put it in slope-intercept form, negative x plus 3. And I would graph, this has a positive 3, and my slope is negative 1, so down one and to the right one, or up one and to the right one. And I would graph that line. And then I would erase what I don't want to keep. This one says greater than or equal to 0. So it would be a solid dot at 0. And it would go to the right because that's where it's greater than. And I would erase anything to the left. Now the question came up yesterday in the other class, like how do you know which one that dot is supposed to be open and which one that dot is supposed to be solid? It doesn't matter. If they overlap, it doesn't matter. What does matter, however, is it still has to pass your function test. So let's say my graph ended up after you drew it, either completely overlapping, like this one went this way and this one went this way. That's going to fail your vertical line test. That's not a function. These are piecewise functions, so they have to pass your vertical line test. So not a function, okay? Something would be wrong with that graph. The other thing you could see is if it's two different graphs, one has a solid dot and one has an open dot, that's totally fine because the open dot is not an actual dot on that graph. So that is a function. So if when you go to graph it, your lines overlap, something is wrong.
Like they shouldn't touch each other?
They can't overlap like this. That would fail your vertical line test, right? It would hit here and here. Fabi. The one we drew up here? Yeah.
Would that be considered like an absolute value, or is that just completely
No, the slope's different. It's just two separate graphs.
Okay.
Yep. It might look like it, but it's two separate graphs. Okay, so we're going to get these with lines. We're going to get these with parabolas. We're going to get these with square roots. We're going to get these with cubic functions. All the things, okay? And in 1-4, we go through all those parent functions. So you'll see more even after 1-4. But the other thing you could do is, let's say you don't know exactly what that looks like. You can plug in points. So for me, I kind of do what we did this first time if it's lines. If it's lines, I think it's easy to kind of find it and erase. But I'm going to redo this whole thing, the other method, and then you get to choose, okay? The other method is to literally plug in points to get your graph. And so I don't do the whole thing and erase. I plug in points from the range that's given to me. So in my first one, I want it to be less than 0. I do include 0, but I make it an open dot. So I would make a little T-chart where x starts at 0 and then goes less than 0. So like -1 and -2. And I plug those points in. So 2 times 0 plus 3 would be 3. 2 times -1 would be -2 plus 3, which is 1. And 2 times -2 would be -4 plus 3, which is -1. And then I plot those points. 0, 3 gets an open dot because I don't want to include it. -1, 1. -2, -1, and I know it's going in that direction, so I only get that portion of my graph. Then I would repeat that for x is greater than 0. So I'm going to start at 0, but I want to go greater than 0 like 1 and 2. And I'm going to plug my points in here. 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. 0, 3 now gets a solid dot. 1, 2, 2, 1, and you draw your graph in that direction. How you choose to do this is completely up to you, especially after we review transformations. You might find that if it's a square or a cubic or something like that, that you remember how you can just shift things around. You might have to plug in a point or two to make it accurate, but you have that option to either graph and erase or plug in points and only graph where those points are. Questions so far? Okay, so this one, look at your piecewise. The top one is what? A line. This one's going to be a line. The second one is parabola. If you remember your transformations, that's down to, but again, we're going to review that tomorrow. So if you don't know it yet, we're going to plug in points. I'm going to do the top, method 1, which is graph and erase, and I'm going to do the bottom, method 2, which is plug in points. So for 2x plus 1, I'd start at 1. And I'd go up 2 into the right one or down 2 into the left one. And I draw the line. Now I want this to be where x is less than or equal to negative 1. So I want to start where x is negative 1. And I want to go from there. And I want to erase the other side. And then for the second one, I'm going to use a t-chart. I'm going to start at negative 1 and then go greater than negative 1, so 0 and 1. I get negative 1 squared minus 2, 1 minus 2, which is negative 1. I get 0 squared minus 2, which is negative 2. And I get 1 squared minus 2, which is 1 minus 2, or negative 1. At negative 1, I get an open dot, 0, negative 2, 1, negative 1, and I know it's a parabola, so my shape is going to look something like that. Yes, sure. Questions? Yep.
Wait, how'd you get the where it starts parabola?
So you mean the shift down, or you mean the physical point?
Where it started,
So I plug in what the very, even though it says greater than negative 1, I plug in negative 1. I just make it an open dot. So you start there, and then whatever direction. Greater than, I'm going to put points to the right. Less than, I'm going to put points to the left. Questions? So the question on your test puts the evaluate and this together. It's literally going to give you a piecewise function. It's going to say find f of negative 3 and graph. So you would literally do what we did last week. The negative 3 I know is less than negative 1, so I plug it in here. I'd get negative 6 plus 1, so negative 5. And that's one question that does not need the graph. And then you're going to get points to graph it. So you're going to graph it by hand.
We're just going to graph it?
Yeah, just like we just did.
Just the same thing?
Well, not the same function, but a piecewise function. All right, last in this section is even and odd functions. An even function is symmetric to the y-axis. So if you're looking at a graph, if I can fold it on the y-axis, it is symmetric, or it is even because it's symmetric to the y-axis. I'll explain this in a minute. An odd function is symmetric to the origin. And for that, whatever's happening in the top right of my graph flips to the bottom left, or vice versa, top left flips to bottom right. Those would be symmetric to the origin. That's visually. Even to the y, odd to the origin. Think odd and origin both start with O. Algebraically, the test is the same as the test for your y-axis. So this says you take f of negative x and you set it equal to x. But if you think about what that's really saying is change the sign on the x. So I make the x become negative x. And if it goes back to the original, or if everything changes, then it's going to be even or symmetric to the y-axis. If it's odd, then we change both. The y becomes negative y, the x becomes negative x. And same test. If it goes back to the original or everything is the opposite, then it's symmetric to the origin, which means it's odd. To do that, you'll have to make f of x y. So you'll substitute y in for f of x. You will not be forced to do the algebraic test. If you have the graph and you can identify it from your graph, that's enough information, okay? Even, symmetric to the y, so something like a parabola would be symmetric to the y-axis, so that's going to be even. And odd, symmetric to the origin. Questions so far? All right, so this one is going to put a bunch of stuff together. We're going to graph the function, okay, by hand first. And then we're going to determine if it's even or odd. And then we're going to determine for the intervals for which f of x is greater than 0, okay? Then we're going to use the graphing utility to verify. So first, I'm just going to graph it. This is the same thing as saying y equals 4 minus x squared. What kind of graph is that? Parabola. If you remember your transformations, it's pointing down, good, and it's shifted up 4, okay? But that's we need to know that for tomorrow, so pretend you don't know that yet. If you didn't know that, you would plug in some points, okay? So I'm going to plug in just generic points, like -1, 0, and 1. So 4 minus a -1 squared is 4 minus 1, which is 3. 4 minus 0 squared is 4 minus 0, which is 4. And 4 minus 1 squared is 4 minus 1, which is 3. I could also have used my intercepts here, so we could go back to what we did in the beginning of the chapter, or the C appendix part, and find my intercepts. If I wanted to find the x-intercept, how would I find it? Zero for y, which is f of x, right? So it'd be 0 equals 4 minus x squared. X squared would equal 4, and x would equal plus and minus the square root of 4, or plus and minus 2. So 2, 0, and -2, 0 are your x-intercepts. And then I can find my y-intercept by plugging 0 in for x. Y equals 4 minus 0, and y equals 4. So that's the other way to do it. You can either plot points, or if you get enough information from your intercepts like you done in your quiz, you don't have to do both. But let's plot all that stuff. So -1, 3, 0, 4, 1, 3 were the points I got from my T-chart. -2, 0, +2, 0 are what I got from my zeros. And then 0, 4 I already have because it was my y-intercept. So this is consistent with what we said, a parabola pointing down, shifted up 4 units. With me so far? Yeah? Okay, so is this even, odd, or neither? So your options are y-axis symmetry, origin, or neither. Is that got any of that? It's good. It's y-axis symmetry because I can fold it on my y-axis and it overlaps, right? Which means it's even. So this graph is even because it has y-axis symmetry. And then the second part says, find the intervals for which f of x is greater than or equal to 0. What does that mean? What does f of x greater than or equal to 0 mean? What does f of x represent? Y. So if I said, where is y greater than or equal to 0? Without this graph, just in general. where is y greater than or equal to 0? First and second quadrants. Everything from here up, right? All of this is where y is greater than or equal to 0. Does that make sense? So now what part of my curve lies in those quadrants? These to these, everything in between those x-intercepts, right? From -2 to +2. So if it asks for the interval in which it's greater than or equal to 0, it is from -2 to +2. And because it said greater than or equal to, it gets the bracket. If it had said greater than, then it would get parentheses. But this says greater than or equal to, so it gets the bracket. Questions so far? Okay, get your graphing utility out. Let's graph it. If you don't have your calculator, you can use the app, but remember for the test, you need the calculator. All right, so I went to my y equals, okay, and I'm going to type it in, 4 minus x squared, enter, and I'm going to graph it. My window's still set from yesterday, so I'm just going to go back in and change my y max so that it's square. And there's my graph. It crosses through -2 and +2. Oh, you can't see it. There we go. Okay, it crosses through -2 and +2. If it wasn't whole numbers, how could I find those points? Second calc, yep. Second trace to the calc menu, and what would you pick? If I wanted to know where it crosses the x-axis, zeros. Okay, my intercepts are called zeros. So if it was not a whole number, because spoiler alert, quick test, it's not gonna be. You're gonna have to find things that cross the x-axis. Okay, those are zeros. Questions? If you go to table, and you're looking for the y values that are greater than or equal to 0, if I arrow up, you can literally look at your y values, okay? From -2 down to 2, they are all positive or greater than or equal to 0. So that also confirms the second part of our question. The graph does, but also your table does. Noah? There's two ways. So if I go to the y equals, you can either hit X, as in the button X here, and then you can hit the caret and the 2, the caret's that guy, and then 2, or if it's x squared, you can also just hit the x squared button. Any other exponent besides 2, you have to hit the caret. You see it? All right, this says use the graph to answer the given questions. So number 1 says find f of 2. This is where the x is 2, the y would be what? 4. Okay, then it says domain and range. Remember, if it's cut off, it's assumed that these are arrows. So left and right, what would be your values? Negative infinity to positive infinity, all real numbers. And range? Bottom to top? Good. Also negative infinity to positive infinity. Number 3 says find the values of x for which f of x equals 0. So now we're saying the y would be 0, or these are also the x-intercepts. What values of x are they at? What are those values of x? 0 and 3. And we list them. That is not a coordinate point, okay? That is a list of all the zeros. 4 says state which intervals the graph is increasing or decreasing. Remember, if there's a constant, you have to include it. It won't be in instructions, but it has to be included. So this first direction is falling, so that would be decreasing from negative infinity to the x where it changes, which is 0. Then it comes back up, so it's increasing from 0 to 2. And then it goes back down. So decreasing again from 2 to positive infinity. There's no horizontal line, so it's not constant.
Is it alright if you put union between?
Yeah, it doesn't matter. You can either list them or you could put union. It's fine. All right, and then 5 says to state all the relative max or mins. Remember, this is anywhere your graph changes direction. So at 0, 0, it's going down and coming back up again. That's going to be a min. And at 2, 4, it's going up and coming back down again. That's going to be your max. There was only one of each on this graph, but remember, if it does it more than once, you need to include all of them.